So you came here to hear me talk about trunks. So I brought a couple of elephants, of course, because, well, warning, this presentation may contain some puns here or there. So if you came for zoology, this is not about it. This is not about elephants, sorry. I brought them, but I'll give you the chance to leave now if you want to. So we'll see how the screen holds up. We had to employ some very arcane technology, VGA, to get it up here because all the connectors didn't work. So we fell back to the old and trusted technology, as we would say. So I'm Jelrik. Hi. And I'm a nerd for hire. I do things with continuous delivery, trunk-based development, as you might have guessed, mob programming, and I help teams that want to grow but don't know where to start. Oh, and I think that code review should be abolished. Like me. So trunk-based development, okay. What is it? Well, there's this website, trunkbaseddevelopment.com. I would say they know what it is, so I took their text. We're talking about a branching model with a single branch, and we're avoiding merge hell and live happily ever after. Okay, so merge hell. Know about that? And automatic merge. Yes? No? Maybe? Okay. So we can say a lot about this definition, we can refine it, sure, but let's take it for now and backtrack a little bit. So why do we need a branching model at all? So what do we want to achieve? We want to deliver high quality software, right? Yes, no, maybe, yes, high quality software, cool. While not burning out our colleagues and ourselves. Yes, no, maybe. Yes, cool. Yes. Yeah, well, you don't know. Some people like it burned out. I don't know. Anyway, let's dive into this. So, deliver. This is the most important word in this presentation. If you take anything from this, I believe that software is only valuable if it is actually delivered to users. If we do not agree on that, we're going to have a hard time tonight. So this is well, one of my main stands here. It's all about software delivery, not about writing software and putting it in a drawer somewhere and never looking at it. So we also want to build high quality software. Okay, high quality software. How can we define high quality software? Right? That's, I think, the question I've had for the longest time. So luckily, some people have thought about this and did some scientific research about this. It's not perfect, there's a lot to say about it, but it's the only, I think they interviewed like 40,000 people for this. They surveyed 40,000 people for this, so it's the only large-scale body of scientific work that I know about software teams and their performance. And this is about the Google DORA group, Nicole Forsgren and the rest. You might know Jess Humble and Gene Kim from other books that they have written, the Phoenix Project, the DevOps Handbook, I think also Continuous Delivery all the way back in 2002 or something. So this is their main presentation of the findings, and they keep bringing out yearly updates on this in the DevOps report. So one of their first avenues of research is indeed, how can we define software delivery performance, as they call it. So basically being good at delivering software, right? There's the deliver part again, that's why it's important. So that's what they are trying to figure out. So I'm going to take their findings and use them as a measure. So what they say is deploy frequency, lead time, and mean time to restore predict your company's software delivery performance. So deploy frequency, how often do you deploy something to your production environment? Lead time, this is a little bit different than what you might think with the word lead time, but lead time is the time from the moment you finished developing your software to the point of it being in front of users. So it's not the whole process of thinking of the idea and stuff, which would be what lead time normally means in my lingo, but this is their terminology. So from the moment the software is done to the moment it is in front of users. And the mean time to restore is the time from finding a user impacting problem with your software until the moment that service is completely restored and that problem is no longer in front of users. There is a fourth metric, and that does not predict performance, but it does correlate with it. So it's not in this definition, but I wanted to share it with you anyway, and that's the change fail percentage. And the change fail percentage is the ratio of changes that you make, the number of changes that you make, how often, how many of those changes do result in a user impacting problem with your software. So that's also a low change fail percentage is highly correlated with the software delivery performance of these three metrics. So what's important here is they predict your software delivery performance. So it's not, oh, they happen in concert or anything. They actually predict your performance as a company. So let this sink in. These are the three metrics, maybe four, you should be measuring for your company, says science, right? And what science says is always true. So who measures these metrics for their teams? Or one of these metrics? Okay. Yeah.
Sorry, what exactly was the definition of software delivery performance?
Software delivery, we'll get into that. Okay. That's, yeah. So, we get into that. Let me address your question at the end, and let's see if you got your answer. And then,
okay, I thought I maybe missed it.
No, no, that's, yeah.
Isn't it like you said, these three things are what you define your software delivery performance, like deploy frequency, lead time, and mean time to restore? Is actually like a model that predicts your software delivery performance.
Yeah, those three predict software delivery performance, but there is more of a definition in the scientific work to measure how or what software delivery performance.
So it's like confounding effects then?
Yeah, exactly.
Because this is like normal equation and confounding effects.
Yeah, exactly. So I couldn't get the whole book into the presentation. That's, of course, it's always a bit of a struggle to. I mean, the first version of this presentation was, I think,
But can we conclude from that these are three main drivers for this?
Yes, absolutely.
For software delivery performance.
Yeah, absolutely. Okay, so that's high quality software. Now the not burning out part. Yes.
It's funny that you come back to that screen because we haven't talked about high quality software. We've talked about high quality software delivery, which
That's
is
fair.
A different kind of thing.
Yeah.
And now you're coming. I'll keep quiet because now you're coming back and it struck me as being different.
Fair. So if I would have highlighted this word.
Yeah.
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 Can we agree? Okay.
Okay.
Yeah.
Oh, okay.
Yeah. No, you have a very good point. You were the first to point this out in 3 or 4 runs of this presentation. Interesting.
Okay.
Thanks.
Never mind.
Thank
you.
So, not burning out, also quite important, I think. So, yes, deployment pain is negatively correlated with software delivery performance, and burnout is positively correlated with deployment pain. Okay, and software delivery performance predicts organizational performance, another performance that is gone in depth about in the book. And burnout is negatively correlated with organizational performance. So we have something linking up here. It's not quite as tangible as we would like maybe, but there is some kind of connection here, right? So, this is interesting. That just froze, I think. Normally I have my laptop here, but that one's over there because the cable was not long enough. So why is this not working?
No, it's working.
Because of software delivery performance.
Yeah, exactly. Exactly. Yeah, blame it on Apple. Blame it on Apple. Let's see if we can get it working. Because this is kind
We
of.
want to accelerate, not decelerate.
Yeah, exactly. Exactly. I can only see like the first 2 lines of speaker notes that I have here, so that's kind of a bummer. But,
Organization. Old school.
sorry? Yeah.
Old school organization.
Yeah, sorry. That's okay. Yes. Okay. So science says we cannot say that burnout is caused by being bad at software delivery, but we can say that they often happen together. Okay?
It's correlation but not causation.
Exactly. So it's not prediction, it's not causation. That's important, right? That difference I want to stress here. But they do happen together a lot. Okay. So back to the trunks. Not that one. I found all the trunk jokes. They're all in here, don't worry. So this one, yes, that's better. So another finding. So high performing organizations that have high organizational performance have the shortest integration times and branch lifetimes, normally lasting hours to a day. And low performers have the longest integration times and branch lifetimes, normally lasting days or weeks. Okay? Something about making more concrete what we're talking about in absolute time. Okay, so let's add these metrics. Okay, we have the deploy frequency, the lead time, the mean time to restore, those were the 3 we had, and the integration time and the branch lifetime. Okay, so we have 5 metrics of a kind. So we have some kind of basic statistical idea of what we want to achieve, right? Those 5 things. So let's get back to the branching models. There's the trunk again. Who here uses trunk-based development?
I have done it in the distant past, but
I
a
must
lot
say,
of people think
my current project also doesn't use trunk-based development because I'm tied to a team that doesn't prefer it. So I invited them here, but well, they're not. So we'll get there someday. Okay, so who here uses Git flow? Okay, and like exactly Git flow, like by the letter or some derivative of it? Yeah, exactly. So other branching models, something of your own making, probably something in between. Yeah. So if you use the branching model I see used a lot, or well, it looks something like, okay, we are agile because we're using Jira, right? So git checkout for my awesome ticket. We're doing amazing work. We do a commit, don't do this commit message. I know it's not a very good commit message, but yeah. But that's a whole talk in and of itself, better commit messages. And then we push it to our origin, cool. we open a pull request, and we wait for code review. Let's not do that in real time. Then we get approval after maybe half a day or so. I don't know, it depends a bit on who you're working with. I have heard people say, yeah, I don't need trunk-based development. My colleagues always get back to me within half an hour. And then I say, yeah, okay, fine. If that is true, then fine, sure. That's not the problem we're solving here. We're solving the more common scenario I see happening in my experience, that this takes a while. And then we do we can also click the merge button, but this is what that does, sort of. And then we get a conflict because, well, half a day went by. Maybe you had to change something, another review, a day went by. Conflicts. And okay, we need to fix them. If we're lucky, they're in the composer.log file, because then we can just rerun composer update for the packages that's about, and then we're probably good. But most often they're in there. Yeah. Okay. So what we can do then is, well, we do git pull. We all rebase, right? We solve the conflicts. We solve more conflicts. And we force push. And then we have to wait for approval again. Or, what most people do, just merge it. But then you have code that was not checked in your main branch. It's also not very nice, right? So either it takes time, or you have unchecked code in your main branch. Both not very good. So this is mainly what I've seen in the companies I've worked with. Is this familiar?
Yes, very
This way of working?
Except of merging it yourself. That's quite outrageous.
So
I just don't get approved.
yeah. Not fair. Okay, you get stuck somewhere in the process. Okay, yeah, cool. Fair. So this normally takes, in my experience, more than a day. And well, we have just seen some heuristic of a couple of hours up until a day. So as Dave Farley puts it, who's a very influential writer, if you don't check that your changes work alongside everybody else's at least once a day, then you statistically produce lower quality software more slowly. We don't want that, right? That's not, this is everything we don't want, I think. So we wanted to produce higher quality software, well, maybe faster, but at least not more slowly. So then the question is, why don't we commit and push directly onto the main branch? Because that's what I'm going to be telling you to do. So, sorry?
We have developers like that. Doesn't end well.
Let's see what we need to make that work, because that is the real question.
Okay.
So what I suggest we do is do git pull. We do amazing work. Before committing, we do a pull again. We rebase, and you can leave those off and just configure them in your Git and never think about it again. So you can just type git pull and do it automatically. Then we get maybe some conflicts, sure, that can still happen. I mean, multiple people are working on something, so you can still get a conflict, but this is before you do your commit. So you have the code that you just made still staged. So you fix only the conflicts that are relevant for the work you just did, instead of all the changes that might have happened in between and having to combine commits and stuff like that. You don't want to do that. So this solves only the relevant conflicts, and you solve less of them. And why is that? Because we don't have the whole merge request cycle. We don't have that half a day or day waiting for a merge request or a pull request to be open and get approval from, well, in my current team, it's a developer and then a tester. So that takes 2 days easily. But yeah, this is just the time it took you to work on the feature. Okay, commit, push. You never see a git checkout or a git switch, right? So we don't switch branches, we're just on the mainline branch here. Awesome, fits on one slide. I needed 2 slides for the other, so this is better, right? So this helps me at least focus on what I'm working on. Because if I have to get back a day, 2 days after developing something, and I've worked for a day or 2 days on something else, I have to get back into what I did. Why did I do it like this? Oh, someone has a question, what was it again? You have to switch branches, my open work on another feature, I have to stash that, or, you know, there's a lot of time involved in focus switching. This, you don't need that. But then, the question is, how does this relate to our goals? Okay, so the first 2 can go hand in hand. Deploy frequency, well, if everything is on the main branch, then you can deploy as often as you like on that main branch. You don't have to. It's still something that's not automatic. It's not every push on main goes to your production environment. That's still a choice you have to make. And that's a whole other talk, continuous delivery. I can do that talk as well, but let's not do that this evening. But they can go hand in hand because there's always one version of your code. And lead time should be low. Well, that ties into the deploy frequency. If you can deploy, then your lead time, which is again the time between you finishing development and your code being in front of users, that goes hand in hand as well. So then the mean time to restore is a little harder, of course, because you still have to find and fix the problem, which is still in the metric of mean time to restore. So you are still debugging stuff, but that's not different from what you would be doing without trunk-based development. But because you integrate your changes right away into the main branch, it will at least not be longer. The mean time to restore will not be higher than with an elaborate branching model other than trunk-based development. So we're at least on the right side of the graph on that. And the integration time and branch lifetime, well, I think that's kind of the definition of trunk-based development. Integrate immediately, get your stuff into your main branch right away. And the branch lifetime, well, we don't have any branches other than your mainline branch, and that should live long, but yeah. So I think we're okay on those. And then this is what trunk-based development would look like. And why don't we all do this? Any objections? Yes.
Where shall I start? There are multiple people in your team, yeah, and you should really have a really close team if you want to also keep in mind if you focus on your problem, which could be a very tricky problem, multiple days developing, and it will result in something someone else is developing in, let's say, file or region, and all along that word, at that time, you need to maintain a stable branch, right? How? Because there has to be a lot of social interaction. Because you want to do that, I want to do this. How are we going to make it together? Which is a good thing because we will talk more in software development. But practically, I don't see that happen. Especially if you're outsourcing software development or something to other regions of the world. That's not a realistic scenario. Another thing I thought about was what about I'm really my mindset is all feature based. If you have a feature which takes us several days, you want to at the end of the day you want to just leave your crap in your own branch and look at it another day because things don't work well the first time. It could be sort of open heart surgery. You want to put it just there and look back later in a completely unstable state. And it would just need extra work to always leave it in a state that others will understand it. It will result in something that will run on others' development. That's the things I'm struggling with. So I love having done this in the past before Git. I've seen both sides, but I personally I would never want to turn back to that. I mean, you didn't even have a big team; it was just 2 persons. And you always had to be to commit something sort of stable enough. And with releases, you could work with tags on the main and just okay, everybody, hands off! We're going to make the tag. It's stable now. And then you make a tag, and it's a fallback point. But that's
okay.
I think that's much more dangerous than just okay, this branch we merged it, and now everything exploded. Okay, we go back and we leave out the branch, but all the other people branches that's stable, and we can just release. You can leave out your piece of functionality because you messed up or something. There are lots of scenarios I can think about where this would be dangerous.
Yeah, there's one thing that maybe is a more generic question. Like you said, you're all for turn-based development, I understand, right? But it won't fit all scenarios.
That's
like you do now. And I think one of the biggest questions is like, when should you not do it? When does it not suit your organization? What is needed for it to succeed? And that is something that.
That's a very good question, and that is the whole rest of the talk.
Okay.
So that's a very good question.
Okay, I'm leaving. So that's the most important thing, right? It won't. Like Max said, like you maybe have a team which is not as solid, or you have a lot of junior developers that actually need a review to get to a certain quality. That happens, right? So that's probably will be one of the topics, right? That you need to have certain maturity.
Or just on a positive, not even with your colleagues, but if you have something that really has impact on the application, I really love the idea to just put it in a branch and not bother the rest with it, and just focus on my own work. I can screw up, I can do anything without endangering the release of the next release.
Okay. So I'm there.
Okay. Yes. So most of my criticism I kind of heard back here, but criticism, I say thoughts, but you haven't really addressed like, so it's trunk-based development, but is it trunk-based deployment, or do you still have feature branches which go maybe through QA phase, or let's say deploy branches or release branches?
Okay, that's a different thing. So feature branches, trunk-based development says no feature branches, basically. So that is before they enter the mainline branch that you have, main or master or whatever you call it. It doesn't really say anything about after that, but I would say if you don't need it, and this is where we get into Pim's question as well, if you need to support multiple versions of your software at the same time, for example, trunk-based development is not going to cut it for you. If you have, sorry, I'm not a mobile app developer, so maybe I'm saying something really stupid, but if you have to maintain multiple versions of your app in the App Store, then this is not going to cut it, because of course you need multiple versions of your code at the same time, right? So that is one of the scenarios that comes to me right away. But if, like most projects that web projects that I do, there is a hosted version of your application that you control, you host, and you have only one version of running at the same time, then this might be for you. So let's get back into that in a bit. So let's see about the prerequisites. What does the organization need to be able to do this? Yeah, objections, yes. Yeah, objections, indeed, so, okay. So the first thing I heard people say, I wrote some stuff down. So the first thing is the 4 eyes principle, right? Code reviews, someone has to check it, the QA process, we need to know that it works before it goes into the main line. And it has to have a code review. Well, I gave a little spoiler at the beginning already. I think code review should be abolished, so here we are, fight me. And something I thought of, so the feature should not go live yet, so I want to I want to still work on that, or it's not ready, not deemed ready by the marketing department who first wants to announce it to the world or something like that. So let's have a start with that. So the 4 eyes principle. How can we do 4 eyes differently instead of pull requests? So I work on this in isolation, there's a hint, and I push something and I forget about it, and 2 days later I see
Pair programming?
indeed. Or my favorite, mob programming. Pair programming is absolutely fantastic as well. So does everybody have an idea what pair programming is? Yes, no,
Yeah.
sort of?
It's like fighting over a screen what is right.
That is
Stylistic choices.
that's
Not going,
that's one way of putting it.
Yeah.
Yes. And mob programming. People heard about that?
Big fight.
That's a bigger fight. If you want to put it in those terms, then it would be a bigger fight. Okay. So pair programming and mob programming only differ in the number of people participating. Pair programming is usually with 2, and mob programming is usually with more than 2. And what you would normally do is you work on one machine, one computer. That can also be done remotely, and then you share your screen and have a video call open. It's also I've done mob programming with 4 or 5 people, 1.5 years long, for almost everything that we did. So, and that was completely remote. So what we do there is we offload all the great ideas that people have during code reviews to the moment where it actually matters, right? So there's nothing more annoying, I think, than putting up your code, you've worked on it, you think this is the best solution, and then a colleague comes in. Yeah, but have you thought about this and this? Oh, but yeah, I think it should be overhauled, it should be this. Right? Super annoying, because either you have thought about this, and it's not a better idea, and you have these and these reasons for that, or, which is, I think, for me, even more annoying, they are right. And you should have thought about this yourself, right? That always gets me most, when they have better ideas than I do. And not because I don't think other people should have better ideas, but because I wasted a lot of time implementing the suboptimal solution. So I think it's more useful to have those ideas at the moment that you're actually working on the code, that you're actually implementing the solution. Have them together, have all those brains together cracking the problem. I have no metrics for productivity on pair programming and mob programming. There's a lot of debate about that. Can you actually be as productive for whatever value of productive? because what is productive is the number of lines of code that you produce productive or anything like that. But as I said, I've done this for a couple of years, 1.5 years fully remote, and I think half a year, 9 months in the office. And we had a sister team that didn't do that, and we split off because we were too big. And then we had 2 teams, so one team was our team fully doing mob programming, and the other team didn't, went full on merge request process and everything, like almost waterfall. Develop, then put it up for code review, then put it up for QA testing, review. We shared the same product owner. The product owner liked us way better because we got stuff done. It's circumstantial evidence, I know, it's anecdotal, I know.
Skill issue?
Sorry?
Skill issue?
Maybe, yes, but what I'm saying is this might not fit everyone, but it can work. And that is something I get a lot of, oh, that can never work. And I just want to put out there that that is not true. It might not work for your current set of people, sure, but it can work. And I think it might be more efficient if you take everything into account. The number of bugs that multiple sets of eyes find before something goes to production. Because when I do a code review, I have a hard time following what is happening in that pull request or merge request because I wasn't there. I haven't seen all the 100 ways that they didn't fix it, that they tried that didn't work. That's all the context I miss. And yeah, you can type a lot of, oh, I tried this and this and this, and okay, but yeah, then you can probably more easily do that in a pair or in a mob. Yeah.
It could also be said that the opposite is true because it's a pair of fresh eyes, not burdened by the process in which you tend to support each other and perhaps in the joint endeavor lose focus because we're doing it well, and if someone will look much more critical if it's separate. So I'm not saying it's
absolutely. That could also be said. My experience is differently.
Okay.
That's
I don't have
no, exactly. That's what I'm. That's what I want to mainly share here. This is the positive experience that I have. I can absolutely understand that some other sets of people, because this, pair programming, mob programming can also be very intensive, right? You're constantly working together. I would say that counterintuitively, mob programming is less intensive than pair programming, because for me, in pair programming, I can never really tap out. I can never say, oh, I lost focus for 5 minutes. And with mob programming, I can just go to that one architectural meeting if I want to, and then come back later. So it gives a lot more flexibility there. So that might be a counterintuitive point that you might think, oh, pair programming, that's less people. So, but yeah, your mileage may vary, absolutely. But I think this can solve your 4 eyes principle problem here. It's okay if we move on. So the second thing, and that's the hardest, and here we go. This is the other thing. I have 2 things that you absolutely need for trunk-based development. 4 eyes principle, okay, but also trust. That's hard. Yeah. I'm not going to sugarcoat this or anything. You have to trust you have to trust that you and your colleagues, but also you, don't forget also you, are going to break stuff. It's going to happen. It's also happening when you do code reviews, by the way. I don't know if anyone works in a team where after a proper code review, nothing ever broke on production. I haven't. So, my take on this, on the trust your colleagues thing, is you have to trust them anyway, because you can't control everything they do anyway. Trunk-based development only makes it more visible, and I think that is a good thing. It front loads it. It makes sure that you have the conversation at the moment it matters. And if you don't do it like this, then the trust is more implicit, and you will find out weeks or months later when they are on holiday and stuff breaks. So this is the hard part. This is not something I can give you a silver platter for. This is how you do it. So the 4 I's principle, I can give you more programming and pair programming, but this is a less tangible thing. But keep in mind that you have to trust before you can be trusted, or what's the, well, I don't know how to say that in English actually. But trust is first given and then gotten or something. Earned, yeah. So don't wait for other people to earn your trust before giving it to them. And that can be hard, especially if you're in a team where trust was a problem before, but you have to break that cycle somewhere. I'd love to talk to you all about specifics about this, but that's very specific to situations, so let's keep that for the beers afterwards, I think. So those are the things you absolutely need. If you don't have these, trunk-based development is going to be pain. And that's, I'm not going to sugarcoat it, as I said. There are 2 more things that I want to put up here as well, that I think are really nice to have, but you don't absolutely need them. So the first is trust your pipeline. So a pipeline, something that takes your code and does quality control on it and maybe brings it to a production environment or not, and that's still a choice that's left to you, and that's not something trunk-based development is about. But your pipeline should be able to tell you 90–95% of the code problems that you walk into. But then the question becomes, okay, how do I know if my pipeline is good enough, right? I have to first have 100% code coverage. That's not what I should say. I think instead of perfection here, you should have prioritization. What cannot fail? What is the most important part of what we're doing? What is not allowed to fail? Otherwise, we lose millions of euros per minute. I don't know, it's a bit much maybe, but some companies probably have that kind of worry, at least. So how can we make sure that we cover the right things? And that is prioritization. So when I worked for an airport in the vicinity of Amsterdam, which I shall not name, we had this exact conversation. So we had a new application, and we got along. We did flight information for passengers. Passengers could book their parking spots. Businesses had their presentation pages on our website. Well, there was a lot. But yeah, what's most important? Okay, so we went back and forth with the organization about this. What cannot fail? And this was a conversation that took place over months, right? So this is not something that you have in one meeting. But we found out, okay, there's a lot of money in parking reservations, but that's not the main important thing. The main thing is physical security inside of the airport. And when does physical security get in trouble? That is the moment that passengers don't know when and where their flights will be leaving, because then people are going to panic, and that's what we do not want. So we had very clearly the flight information for the coming few hours. That is the most important thing that cannot break. And that is a daring choice to make for the organization. Because if the parking reservations wouldn't have worked, they would have lost quite a lot of money each day. But they still said, no, it's the flight information, because that's physical security. And I always like this example, because a lot of organizations don't dare to make that choice. And we had to drive that choice, right? We had to push them. As developers, as our user experience research team, we had to push the organization to make that choice, because they didn't want to. I mean, everything is important, right? Everything is most important. Everything has to work always. But that was not an acceptable answer. So what we started with was just the flight information for the coming few hours. If that was fine, then software was good enough to go to production. And we had a lot of monitoring that was built up after that to make sure that the application kept working, of course. And with every feature, we threw in new tests, of course. So that grew, but that could grow, because we knew what was the most important part, and we could start. We could at least start with a pipeline that we could trust. So that's trust your pipeline. So yes, I would advise you to have a strong quality control, automated quality control system in some sort of pipeline. I call it pipeline, but it's any kind of automated quality control. But when push comes to shove, if you pair or mock programming your changes and then you push to your main branch, there is no quality control lost from developing separately, letting someone code review and then merge, right? There's still two pairs of eyes that have seen the code. So you won't be any worse off without this. I would still advise you to have it, but okay. And then the last thing, feature toggles. It's sometimes nice to have, sometimes you don't even need it. It greatly depends on your business and your software, what you're making. And generally, I think it is a good idea to decouple features and releases of features from integration. So from merging your code into the main branch. Because I've had this a couple of weeks back actually. We had a new feature. So there had to be a invoice payment link next to the overview of all the invoices, right? So you had an overview of all your invoices, and there should be an ideal payment link. Okay, cool. But the marketing department really wanted to send out an email when that went live, because otherwise they were afraid that people wouldn't understand it or something. Sure. But then the question becomes, okay, how do you do that? Do you do that by creating a branch and making that link, have a branch, and then in a week's time when marketing wants to release it, we merge it. That's one way of doing that. That's not what trunk-based development should be about, but that's one way of doing it. But then marketing decides, oh no, there's a more important announcement that we have to make first. We postpone it for 2 weeks because we don't want to send emails too often. Okay. Then we have a branch that lives for 3 weeks instead of 1. We have to keep it up to date, fix the problems in the composer log, for example. And then we have a long living branch. That I don't like that. I don't know about you, but that's, yeah. It takes me, back a couple of years. It feels inefficient. Because what we could also have done is just merge it, right? But then the link is there, okay, but that's what we have feature tools for. So if you put, I think it's 2 extra lines of code. Okay, a little bit more because you have to make this work, sure. But something like this, you can base on environment variables, something you set during deployment, even something in code that you only have to make a very small commit later to enable the feature. And then it's still part and integrated of your main branch. So you know that all new code that is developed in the meantime, in those 3 weeks maybe, will still integrate with it because it is already part of the main branch. And what you have to watch out for with this is that they are kept around. Yes. That's yes. There are. That's a very good
Where's
point.
the to do?
Absolutely.
And plus the code behind show payment link isn't executed, so it could go to all the static tests in perhaps, but unit test may hit it perhaps. Yeah, you gotta call it separately. Yeah, you can cover that with unit test. Thinking about it.
Well, you can.
If the code is never hit, then you can drag it along. But when you enable it, it could go boom there, and then you have the same situation as that you keep it in a separate branch and do a rebase just before release, and there it goes boom. But when with the rebase, if it goes boom, it's your problem and not the rest of the company.
Absolutely.
So, yeah,
But
you can cover that with unit tests.
well, not even only with unit tests. You can also when I implemented this most recently, what we had was a very simple dashboard for the product owner, for example, who could just click, I want to enable this on my computer, then a cookie would be set on their computer, so they could manually see how it would work. But you can also make that work based, for example, on environment variables.
Yeah,
and if you do environment variables, you can also do it in your integration tests or your whatever we call it, functional, anything that's a higher level than a unit test that actually runs your software.
But essentially, if it doesn't get enabled eventually, you just end up with a bunch of dead code in your code base.
Absolutely.
Yeah, there's also lots of guarding going on because
Yeah.
just the show payment link is quite innocent because it's in the display thing. But perhaps deeper in the code, a lot of info has to be gathered to show the payment link, perhaps. And is that executed? Should it also should it just execute it and just don't do anything with it?
Is it a problem?
When it becomes slow, should we put the feature is enabled everywhere, and then there's really no way of cleaning that up later because
Why
it
not?
is there, or you just search the code for feature enabled and periodically review which things are now obsolete, which switches.
Well, you have to toggle the feature on at some point. That's the moment you can remove this, right?
Okay.
Or just after, I
Yeah.
would say, just enable it, see if it indeed still gets traction, or maybe partially enable it for 10% of your users, something like that. And I heard a question.
Oh, like the question was like, yeah, and all the logic behind, should you then invoke that? Yeah, and I said like, yeah, why not? As long as the end user doesn't see it, it's fine, right? You can do
You've never
everything.
had slow code or something that is
Yeah, but
just
if
on the
it's-
border of
Yeah,
acceptable?
but you go back to slow code, but one of the first topics that Jelrik said was trust. And nobody builds the code to be slow.
And
No,
if
but
and
you
if
can-
it's slow, then it's gonna be slow
Yeah,
when you enable
I
this.
know, but-
And that's a problem at that point anyway, right? So
Yeah.
if it's too slow to run, then
Yeah, you have a point.
Feel fast.
yeah, then you know that it's slow. I would say, but
Yeah, but as long as the end user doesn't see it, right? You can hide the menu item. Just for
Yeah.
example, just hide the menu item. All the logic can be there, everything can be there, but nobody even notices that it's there. Even though that it's not even secure or whatever, that you can access it via direct URL, nobody even cares. So
But if and when a feature would become stale like this, you run into the exact same problems as with a long-lived branch, essentially. That
If
is-
you have it, if you have it under your or in your test suite, covered in your test suite, then it shouldn't, right?
No.
It's just there taking up space and just, yeah.
but you can also do static analysis, right? You don't have
Yeah,
it's
you have
it's
it
even
static
invoked.
analyzed in the context of the other code. So that's the point I'm understanding here. It's in the context of the other code, and then you can even perhaps unit test it, isolated.
Oh, yeah.
Just, so not in a view layer or something like here, but you can if it's some sort of plugin, you can separately unit test it and static analysis in the context of the main code. So I do see the benefit of that.
And it at least doesn't give you a lot of conflicts to solve later when you want to merge through that into this and then hope that it still works. Because you can, if you have it integrated in your code and in your test suite, then you still have a proof of that everything works, every single of those scenarios. So either the is enabled or the not enabled.
The main thing I'm struggling with is mostly just that I don't like the idea of having unused code in my code base. Like, it shouldn't be there if it's not being used.
It's
in my opinion.
not yet used.
Yeah, but
Yeah.
that's what I'm struggling with mostly. I get the benefits of having it in there for the testing purposes, but I don't like the idea of it being there in the first place.
But it isn't only for the testing purpose, it can also be for internal to review it and, oh, you have a new function, but is it really what we want? I'm currently working on a module where you have a feature toggle on it. It's 6 months ago that we started on it, but a lot of things changed, so it's still not used by our customers. We reviewed the internal, oh wow, we forgot a lot, so change it and yeah, it's not a development problem or more a safety problem. But for that it's very useful to have a feature toggle because they can review it and see.
I get that, but at that point, what's the benefit to this rather than having a branch where the user can test it?
I don't want to merge it. I really shouldn't want to merge it.
I can answer that. Having one version of your code, integrated, everything together.
I worked previously in an enterprise customer, right? And what you mentioned, like very strict in release notes and release cycles, right? You have to request a release, it takes 3 days to process it. Then you have to request it. You can only release during 12 o'clock and 1 o'clock at night in a strict window. So if you want to enable a feature, business people want to have control over when the feature gets enabled and not the pipelines you have. And that's the difference. That's why you probably want it. Split the actual delivery of the feature from the delivery of the code itself. It's not up to a developer to determine when is the feature on the production environment and when it's in use.
So another example, at Schiphol, sorry, I should.
Lawsuit.
Yeah. We worked on a couple of self-service kiosks, so touchscreen terminals where people could get some kind of information. We used feature toggles there as well to actually experiment with stuff on the machine itself. We had like a testing setup in our office, but going into the airport and figuring out how that would work was very valuable there. So there was a barcode scanner on the thing, so people could scan their boarding passes. So we had like a secret master override barcode, and that would show us the list with feature toggles, so we could enable them and play around with them on the real thing. So that is also something, and that was our deployed code because it was on the actual production environment.
So realistically, you could enable it on all the others anytime you wanted to,
Yeah.
but you have the ability to test.
Exactly. Yeah.
And you can scan the code itself to actually determine if it's that code. You just have to scan it enough to determine when did I invoke it for the last time I scanned it, and if it's never for like 1 month, you know it's that code.
That's another thing. Where do you draw the line between dev code?
But maybe you can reverse it as well, and the whole dead code thing. Maybe it isn't dead.
It's not alive yet.
No,
It's unborn code.
but from
Yeah.
a developer perspective, it
not.
is not dead code, because the decision whether it is used is not up to that developer, as Pim just said.
Yeah.
So it is live code. It's just based on a toggle someone set somewhere. That is not you.
Yeah, but I get the frustration, right?
Yeah,
We
yeah,
all
sure.
know that business
Sure.
people tend to
Of
ask
course.
something, and then
Yeah.
at the end, oh no,
Of course.
I don't need it for the upcoming 2 years,
Yeah.
right? And that's something you don't never want in your code,
Yeah.
of course. That's-
So what I, and that's important. It's we're diving into the feature toggle thing a little bit more than I was planning to, but no, it's a very good question. You're asking good questions. So I think there's a very separate way of thinking about feature toggles. So you have the feature toggles we are talking about, short-lived, one way. They go live and then they disappear. But there's also the sort of feature toggles that you can have in modular systems that multiple customers
This
use.
one customer. and
Exactly.
this one,
And
yeah.
that is not the feature toggle I'm talking about here. I mean, that has its place, but that's a very different philosophy here.
That's probably where my.
Yeah, exactly. So this should be one way. You enable it for everyone, and then all the if statements should go. And that should not be that many, but it depends a bit on your code. But for example, I'm working on APIs a lot. I never use feature toggles. I just progressively update the output of the API, which is JSON, which is, well, communicated to everyone. Extra elements can happen at any time. Yeah, if I change something backward incompatible, then I have to make a new version, of course. But that's also not a feature toggle. I just release a new version of the API. So I don't use this as much, but if you have actual end user facing applications, you might want to do this in your view layers and stuff. So that's, yeah. So this about feature toggles. Let's see, where were we? I already mentioned everything here. Okay. So this is what we need, and this is what we might want. I would strongly advise to think about it at least, to see what it's about. So I think we have everything to try trunk-based development. So pair programming, mob programming. You don't need to go all in right away, right? You can try this. You can say, I'll come back to you. So you can start this for a feature or a bug fix. You can say, okay, let's get together, 2 people, 3, maybe 4, the whole team. It depends a bit on your team size. I wouldn't say do this with 10 people, but maybe your team is too big then. But that's a whole other can of worms. Yes.
Yeah, well, maybe it's coming later, but my biggest worry is about how you get a stable branch that's ready to be deployed. Because I test my own code, and of course I'm blind for my own mistakes.
Sure.
So I put it on main, somebody else finds an issue,
Yeah.
I have to go and fix that, but in the meanwhile we cannot deploy it because the main branch is now with a bug in it. And then I fix my bug and somebody else pushed this code, I find a bug in this code, and so we cannot deploy. And in my vision, I think there will never be a moment we can deploy. Because there's always some feature that has a bug in it. How do you cope with those kind of scenarios?
Yeah, in my experience, I've introduced this I stepped into a team where they already did this, and I introduced it in 2 more teams. And what I've seen is that yes, in the first couple of weeks, this exact thing is going to happen. Everything is on fire all the time, and you're running around panic. Not that bad, but at least there's always stuff is gonna break. In my experience, people are very quick to learn from that. So if everything is on fire all the time, nobody's really happy. So then, if you are pair programming or mob programming, like doing the 4 eyes principle, you get better and better at spotting those really user impacting problems, because there's bugs and bugs, right? There's the website doesn't work at all, or this new feature misses one validation rule on this one form field that's optional anyway, right? That's really different kinds of bugs. So in my experience, you can catch a lot of that by doing this, by getting better at this. And I know that's a bit of a, it sounds simple, but I have seen this happening multiple times, and in all situations I use this. So yeah, if you, I don't think it's very different if you pair program or mock program and push to your main branch versus doing your work alone, putting up a pull request and letting it be code reviewed.
Well, that's true, but we have a different develop branch where we can, if we push to a test environment, everybody can test, and also the product specialist and non-developer people who actually know what it should do can test, and then we so that can break all the time, and then once every 2 weeks we put it to an ACC environment that should be stable.
So this is also about functional things. Okay. Yeah. What I used to do if we do mock programming is pull the user experience designer in, or pull the visual designer in. Is this how you want it, or not, while working? So that's the same actually as the whole code review thing that I mentioned earlier. You want them there at the moment that it matters, not afterwards when you have to get back to the same thing. So I think a lot of that can be caught in that kind of a cycle as well. If you're working closely together as a team and not only as developers.
Yeah, so that's one of the requirements that the organization you're working with should be able to deliver somebody with knowledge what they actually should do.
Well, yeah, but how can you do your work otherwise?
Yeah, they'll have to test it.
Yeah, exactly. But why is the tester not with you developing the code then?
We have more developers than testers, so cannot be everywhere all the time.
Yeah. Yeah.
Oh.
Yeah. Fair. So, what I'm telling you to do is this, not this. Yeah. Sorry? Okay. So,
It still has to sink in.
yeah.
Oh yeah, oh no. Yeah.
Yeah, this.
Yeah, leave that on.
I get confused even looking at it. Anyway, so yeah, and finally a reminder of why we want to do this. We want to not burn out our colleagues, or at least I don't want to. So that's it for me. We can talk a lot more, of course, but this was the prepared part of the presentation.